All right, so here we have a spring-loaded marble shooter, and it's going to be launching this marble horizontally off the top of a table. The height of the table is 1 meter, and the marble lands 2 meters away from the edge of the table in this cup here. The spring constant of the spring, which the spring is what launches the marble, that's where all the motion begins. The spring constant of the spring is 100 newtons per meter, and lastly we're given the mass of the marble as 50 grams or 0.05 kilograms. All right, so the first question is, what is the launch speed of the marble if it lands in the cup, which is 2 meters from the edge of the table? So this first question is actually a kinematic problem. We're going to be solving this with projectile motion. So when the marble leaves the edge of the table after being launched by the spring, it has an x velocity. So we'll show that right here. So this velocity here is Vx. And the thing we know about the x velocity is it remains constant the entire flight through the air, assuming no air resistance, which we definitely can assume. So we are looking for this initial x velocity. Now the initial y velocity as the marble leaves the edge of the table, there is no y velocity simply because the motion is only in the x at the moment the marble leaves the table. So here's our x direction, our y direction. When the marble leaves the edge of the table, the velocity is perfectly x, meaning that there is no y velocity. Sign conventions are going to be important here. Our vertical displacement is this 1, and we're going to want to make this a negative 1. That's going to be negative y equals negative 1 because the marble is traveling down vertically. So let's put the sign conventions here. Down is negative, up is positive. Here's our sign convention. And then the other thing we know about projectile motion, and I said this already, but not in this way, but earlier I said that the x velocity remains constant, this x velocity here. Another way of saying that is that as the ball flies through the air, the x acceleration is 0 meter per second squared, and then the y acceleration, the vertical acceleration, is gravity, which is negative 9.8. Okay, so to do number 1, what we're going to do first is we're going to solve for time in the air. How much time does the marble spend in the air? And in this situation, there's not enough information to figure this out with the x direction, because all we know about the x direction is that it travels 2 meters in the x and that the x velocity is constant. There's no way to get time from the x direction, but we can find time with the y direction. So using the first motion equation, the first on my list, y equals 1/2 gt squared plus vy initial t. We said up here that there is no y velocity initial. As the marble leaves the edge of the table, the velocity is only in the x, so vy initial is 0. So now we can solve this for time. So doing the algebra, we get t equals square root 2y over g. And now we plug in the numbers. Our vertical displacement is negative 1. Gravity is negative 9.8, so the negatives cancel inside the square root. And this gives us a time in the air of 0.45175. So don't round this because we're going to use this in a later calculation. Now that we know the time in the air, we can solve for the launch velocity, which is our Vx, the x velocity as the marble leaves the edge of the table. So using the first motion equation again, x equals 1/2 at squared plus vxt. As we said right here, up here, there's no x acceleration because we know the x velocity remains constant, so that goes to 0, and we're left with x equals vx times t, which means that velocity x is equal to x over t. And our x displacement is this 2 meters. So 2 meters over our time, 0.45175, gives us the answer to the first question, which is 4.4272. And don't round that because we're going to be using it in our next calculation. Okay, in the second question, we're asked to find how far the spring was initially compressed in order for the situation described to have happened. For the marble to fly 2 meters horizontally from the release point from a table that's 1 meter high. So I have here a sketch of the problem. The spring has been compressed a distance x. We have the spring constant as 100 newtons per meter. And in part 1, we found out that when the marble comes off the spring, so we'll put the marble right here, when it comes off the spring, it's traveling with a velocity of 4.4272, unrounded here. So using conservation of energy, we have our master equation right here. There is no non-conservative force in this situation because we're told in the question that it's frictionless, and the only force affecting the motion is the spring. And as you know by now, the two conservative forces are gravity and spring. If gravity and spring are the only forces affecting the motion, then it's a completely conservative situation. So we can take the work non-conservative and just cross it out. So over here is the initial. So let's go through the energies. We start with no kinetic because the marble starts at rest before being launched. There is no potential of gravity because this whole problem takes place on the same horizontal surface, which we'll just call this horizontal surface here the 0 point. So there's no potential of gravity and no potential of gravity final. And then there is energy in the spring. The spring is loaded initially. So all the energy before the marble's fired, it's all in the form of potential of spring. We do have kinetic final because when the marble leaves the spring, there's a velocity, and there is no potential of spring final because the energy in the spring has been fully released. So we're left with potential of spring initial equals kinetic final. So now we plug in our equations. Potential of spring initial is 1/2 kx squared. Kinetic energy final is 1/2 mv final squared. We can cancel out the 1/2s, and then solving for x, we will get square root mv final squared over k, and we can pull out the v to make it a little easier. So velocity final was 4.4272, and then square root, the mass of the marble is 0.05 kilograms, and the spring constant is 100 newtons per meter. So this gives us an answer of 0.099 meters, which we can just round it off to 0.1. Okay, in the third question, we're told that friction is now present between the marble and the barrel of the shooter, the shooting device. And what this friction is going to do is it's going to lower the final velocity of the marble as the marble leaves the edge of the table here. And because there's a lower velocity when the marble leaves the edge of the table, the marble's not going to fly as far through the air. So this 2 meters that was initially given now becomes a question mark. So we're going to label this x equals question mark. So if there's a 1 Newton frictional force acting on the marble as the marble slides down the barrel of the gun, what will be the new horizontal distance that the marble flies through the air before landing on the ground? So this is a kinematic problem. In part 1, we found that the time in the air was 0.4517 seconds, and this is still our time in the air because the time in the air does not depend on the x direction. And with friction present between the marble and the barrel of the shooter, that's going to affect the x velocity of the marble as the marble leaves the edge of the table. But the y velocity, if you look back at what we did in part 1, the initial y velocity is 0. When the marble leaves the edge of the table, there's no vertical velocity. The height of the table is not going to be changed. And the acceleration of gravity, which is our vertical acceleration, that's not changed. So the time in the air is still 0.4517 seconds. So to find this horizontal displacement, the kinematic is going to be x equals 1/2 at squared plus vx times t. And there is no x acceleration. The acceleration in the x direction is 0, simply because x velocity remains constant as the marble flies through the air. The x velocity is unchanged. And another way of saying that is there's no acceleration in the x. So x is going to be vx times t. This is the displacement we're solving for. We already have time in the air, so what we now need to find is the x velocity of the marble as it leaves the edge of the table with friction present. So looking at this diagram, so here's the edge of the table. When the marble leaves the shooter, the velocity is perfectly x. This is the velocity we need to find, this x velocity, in order to figure out how far the marble flies through the air. So to get this x velocity, we're going to use conservation of energy. Friction is present, which is a non-conservative force. So I'm going to change this NC to friction, and it's minus because friction removes energy from objects, never adds energy. So this is minus work of friction. Okay, so let's go through our energies. Over here is the initial. There is initially no kinetic. Before the marble is launched, it starts from rest. Kinetic energy is 0. We have no potential of gravity, initial or final, because the whole situation here as the marble's being launched, it all takes place on the same horizontal surface. So there's no h values at all. In other words, this is our 0 point right here. Okay, we do start with potential of spring because the spring is loaded and there is work of friction. Okay, kinetic final is present. When the marble is off the spring, it has kinetic energy, and there's no spring energy final because the spring is fully unloaded. Okay, so what we're left with is potential of spring initial minus the work of friction equals kinetic final. So this is 1/2 kx squared minus friction times distance, which we called x up here. And I want to point out that friction is parallel to this distance, to this 0.099 meters. Whenever you use the work equation, the force and the distance must be parallel. Okay, this is equal to 1/2 mv squared. And we're solving for this velocity. So doing the algebra, we get velocity equals square root kx squared minus 2 friction x over m. So plugging the numbers in, our k is 100. Our x value is 0.099 meters. That's how far the spring was initially compressed. minus 2. Now friction is, it was given as 1 Newton. That's a given value. That's a 1. And then the distance that friction acts for is 0.099 meters. And then the mass of the marble is 0.05 kilograms. So this gives a velocity of 3.955 meters per second, which is the launch velocity. That's this x velocity when the marble leaves the edge of the table, 3.955 meters per second. So now we come back to our kinematic. We've figured out the x velocity when the marble leaves the edge of the table, 3.955. The time in the air was calculated in part 1 to be 0.4517, giving us a new horizontal displacement of 1.78 meters, which is the answer.